Alright guys, I'm going to work number 3 on worksheet side 1 of the Redox reactions half reactions method. So we're going to start here with this formula to start with. Manipulate my camera here a little bit. Now remember, step 1 is going to be determining who's being oxidized and who's reduced. So remember, Leo the tigress is Gur, so let's first figure out our charges. I'm going to write in a different color to get my charges up there because I want to be able to erase them so they don't trip me up later. It happens to me a lot. What, Asher? As long as you're quiet. Alright, so we've got 3 of the oxygens. Remember, oxygen is always going to be a 2 minus charge, so that puts this 2 times 3 is a 6 minus. But the net charge is minus 1, so that means my net charge for my chlorine must have been a 5 plus, because 5 plus negative 6 gives me that negative 1. Negative 1 charge on my chlorine here. This one, if it's a compound by itself, it's going to be a 0 because it's happy and stable just the way it is. Now, again, 2 times 2, so 4 minus, which makes this a 4 plus. Alright, so then we're going to look. We go with the chlorine. Goes from a 5 plus to a 4 plus. So you're going to ask yourself, did it lose electrons or gain electrons? And the reason I know I'm looking at the perchlorate and the chloride is because it's essentially the same compound, just changing different. It's being reduced. So we're going to say grr, because it gained electrons, therefore was reduced. Now my chlorine went from a minus 1 to a plus 4, or sorry, a minus 1 to a 0, so it lost of electrons, oxidized. Alright, and again, the reason I could see, even though chlorine was present twice, was that you set them all up, and if this chlorine is bonded with this oxygen here and over here, then I can be clued in that that's a pair if this one is chlorine by itself. Alright, so then I'm going to separate it out into my half reactions, and I get ClO3 with a minus 1 charge. So again, I'm going to pull this guy and write ClO2. Alright, so when doing the redox reactions, this one is in acid. So remember, in acid is where you're going to balance the easier way. So in base is harder because you have the hydroxides and you cannot have the H plus. So we are going to add H2O and H plus until it's balanced and then follow all the normal steps. So I have 2 or 3 oxygens over here and I have 2 oxygens over here. So I am going to add 1 H2O. I don't know why I wrote a 1 there. You don't need to write a 1. My brain's being silly here. And then you have to balance with the hydronium. So I have H2, so I have to add 2 H plus over here. Now I'm going to look. My chlorine is balanced. My oxygen is 3 and 3, and my hydrogen is 2 and 2, so all the atoms balance out. Now I'm going to check the charges. So my net charge here is a minus 1. My net charge here is a 2 plus, therefore my net charge on this side is a plus 1. Over here I have a neutral, so it is a neutral charge. To get plus 1 to neutral, I'm going to have to add 1 electron. Alright, this guy is balanced. This is a neutral charge now. So we're going to go on, and that was my redox reaction. Now I'm going to do my oxidation reaction, and it is chlorine to chloride. Alright, there's obviously no oxygens to add, there's no hydrogens to add, but what you do have to do is throw a 2 out here to balance that there's 2 chlorines, and that means you have a 2 minus charge here, and you have a neutral charge here. So to get this side to a 2 minus, you're going to have to add 2 electrons. My charges are balanced, my atoms are balanced, so it's good, but I've got 2 electrons here and 1 electron here. So I'm going to multiply the top by a number to get that 1 electron to 2. So I have to take the entire thing times 2. So this I'm going to rewrite down here. So my 1 electron becomes 2 electrons, which will cross out. I just throw a 2 out front, my perchlorate. And that becomes a 4H plus. You can't see what I'm doing. Alright. To form 2ClO2 and 2H2O. Now I'm just going to add these guys in. So when I do that, that crosses off, and I'm going to add Cl2 and 2Cl minus. Now my last check.
We need some lasers for something. I promise we won't turn any eyes.
Honey, you can't have any lasers, okay? No lasers. I know. Mom's got to finish this. Hold on. Okay, so I've got 2 and 2 for chlorine, which is 4, and I have 2 and 2, which is 4. Again, the last check, I know we've just been double checking with an answer key, but in reality you can double check by saying, are all my atoms balanced and all my charges balanced? That's really the goal of this, is balancing it, but in the form that an acid or a base would balance. An acid is an acid because of these guys, H+, and it has water. In order for something to be an acid, it must be in an aqueous solution, hence the H2O. And then in a base, think of sodium hydroxide, we have the OH and water. So that's why we balance with those, but we need to remember that the end goal is that the whole formula is balanced. So 4 chlorines, 6 oxygens, so that's 4, 5, 6 oxygens, hydrogens 4, hydrogens 4, it's balanced, and my net charge is 2 minus, 4 minus, 4 plus, so 0, or neutral, and neutral. So check. I had a few questions about the order. There is no specific order, no. So if your answer key is just flipped in a different order, that's fine. As long as what is on the reactant side is on the reactant side and product side is on the products. You can also double check when you're done that you can't simplify, but because this chlorine is a Cl2, I know I can't simplify. Alright, so again, that was in an acid. That is my balanced equation right here. That guy. Alright. Now, when you are balancing in a base, there's just a few things that you do differently. So let's pick one here. I'm going to do number, I'm calling it number 10, but what is it? The zinc and nitrate problem. I was told that it having that hydroxide made it tricky, so that's why I picked this one. So if you look on worksheet 1, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down. Number 10 right there. Again, this is on page 1. So we are going to start by realizing that this is in a basic solution. So again, the other one was in an acidic solution. This is in basic. So the end goal is with the hydroxides. But we will start by balancing just like we did for an acidic solution with H2O and the H+. And then we will progress to that anywhere we have the H+. Because you are not going to have this in a basic solution, so we have to change it to this. But when you change it to a hydroxide, you have to do it to both sides. And if you have a hydroxide and a hydronium together, hydrogen plus, you form H2O. Okay. Let's start by writing out the equation and determining who are our oxidizing and who are our reducing agents. So I'm going to have zinc and nitrate with a -1 charge to form zinc oxide, 2- charge, and a 1. There we go. Okay, so let's see who's oxidizing and who's being reduced. I'm going to use my pencil again here. Shouldn't have written it up so high there. Again, compound by itself. So 0, this is a -1, therefore if this is a 6 minus, this must be a 5 plus. Each one of these is a -1, and there's 4 of them. So that's a 4 minus. Therefore, this must be a 2 plus. This must be a 3 minus, so this must be a 3 plus. Right, I'm gonna double check that I didn't make any silly mistakes. The kids giggling in the background might throw me off a tad bit here. 3, yep, okay. So, what I'm gonna see is my zinc is going to be my oxidizing, Leo, again, because loss of electrons. So if you get positive, that means you lost a negative electron or more. And then you never look at the oxygens for the oxidizing or reducing. So my next one's going to be nitrogen. And from here to there, my charge went down, which tells me I gained electrons. Grr, I almost wrote oxidizing. So reduced. Now I'm going to take each of these and write them out individually. So this is hence the half reaction. What, honey? Aww. Alright, so I have zinc on the left-hand side and I have zinc hydroxide on the right. What I have over here is 4 oxygens essentially. So remember, when you're doing in basic, you're going to start off just like you did in acidic, but after you do your H2O and your H+, then you do something different. So let's start off with our H2O. We have 4 oxygens, so we're going to add 4 H2O. Because we have 4 of these, it's 4 times 2 hydrogens, so that's 8 hydrogens. So add 8 H+ over here. Now, oh, nope. So that is my instinct, but then I realized that I've got 4 hydrogens here. So I actually only need 4, because 4 plus 4 gives me the 8 that I need. Okay, that's a step you might not have thought of it off the bat, so if your answer didn't come out right, I'm guessing it might have come here. If you realize you have hydrogens here, you can subtract that from how many H+s you needed to add over here. Okay, so now my hydrogens are balanced, but remember, this doesn't exist in basic solution. So what I have to do is I have to add a hydroxide for every one of these. So 4 OH, and they each have a -1 charge, which that's going to do some magic, but I have to add it over here if I add it over there, just like in algebra. OH minus. Okay, this entire OH has that minus sign, so I really should probably have parentheses around that and a 4 out front. Okay, so now I added a 4 OH here, each with a minus charge. And here, this actually turns into 4 H2Os. Now I have 4 H2O here and 4 H2O here. Well, that felt silly, but what it really did give us is the 4 hydroxides over here that we wouldn't have known necessarily. I mean, maybe, because you see it here, it should make sense now. But let's check to see if we're balanced. 1 zinc, 4 hydroxides, 4 hydroxides. And this all crossed off. And our net charge... so just like before, now we're back to the same process as acidic again. The only different in basic is that OH to the H2Os. So now we're going to balance our electrons. This is a neutral charge. This is 4 minus, and this is a 2 minus. Alright. So I have to add 2 electrons over here. Oh, no, this is 4 minus, this is 2 minus, so I have to add 2 electrons over here, sorry. Because I want to get to -4. Okay, so I have zinc plus 4 OH minus yields zinc hydroxide with the 2 minus charge plus 2 electrons. Now I'm going to do my other half reaction, which is the nitrate. I'm afraid I'm going to start working off the page here on this. Here. So now I am going to do my half reaction with my nitrate. So I have NO3 minus yields NH3. So just like before, balance our H2O. So I've got 3 here, so I have to add 3 H2O. That gives me 6 hydrogens, so I have to add 6 hydrogens over here. feel like I'm missing something. Oh, I went backwards. Oh my goodness. Please tell me you didn't do that with me. Please tell me you're saying, what on earth are you doing? I have 3 oxygens here, so I have to put 3 H2O over here. Now I have 3 hydrogens times 2, so I put my 6H plus over here. Now because I have 6H plus over here, I am going to do the basic magic here and add my 6 OHs, the minus charge. Alright, so 6 OH. But then I have to do it over here. Alright, remember this one turns to 6H2O. So that crosses off. I have 3 H2O over here and 6 over here, so it's actually going to turn into 3 H2O. Now my work's getting crazy enough, it's going to be hard to see here. Okay, so I've balanced my hydrogens and my oxygens and my hydroxides. Now let's double check that my atoms are balanced. I have 6 oxygens, 6 oxygens. Hydrogens, I have 6. Ooh, shoot, I did the thing here where I didn't pay attention to that. Alright, so it should have been NH3. I should have added a 9. Oh, let me look. My nitrate would have been a 3H2O, yes. The 9OH. Because I have 3 hydrogens. Oh, that's why. Shoot. So instead of 6 hydrogens over here, I would have had to add 9. Alright, you're going to see me scratch off a whole bunch, so I'm going to rewrite this one so you can see. Yes, Asher. So I'm going to rewrite so you can follow what I'm talking about. So I still have my nitrate, and it reacts to form my NH3 that I had. Okay, so what I had done was first I added my 3 H2Os, which gave me the 3 oxygens, but then I had 6 hydrogens plus 3. That's where I went wrong. I put 6 over there, and I should have added my 3 hydrogens to it to get 9H plus. What, Asher? Honey, what?
Sticky notes moving?
Let me guess, you're trying to do a prank.
Yes.
Alright.
But
Don't tape anything shut on me, okay? Alright. Step back, guys. I'm recording. Okay, so my 9H plus and my 9OH turns to 9H2O. And I still have my 9. I'm going to rewrite the whole thing because I got a little crazy on you guys there. I want you to see the full picture here. Now you can see that I have H2O on both sides, so I'm going to have to simplify that. So I've got 3 over here and 9 over here, so it'll be 6H2O. Alright, now what we're going to do is double check that it all balances out. I'm going to start just by writing at the top of this page here. Rewriting it as I have it. Honey, please no. So now I am at NO3 with the -1 charge, and 6H2O reacts to form. Nope, no paper towels, honey. Plus 9OH minus. So this is what I've simplified it to. Alright, now I'm going to have to check my charge. Well, let's double check our atoms first again so I don't make sure I didn't mess that up. So 1 and 1, 3 and 6, so 9. 9 in oxygen. Hydrogen's 9. Hydrogen. Oh, hydrogen's 12, sorry. And then hydrogen's 12. Good. Thank goodness. Alright, now my net charge. I've got a -1. Any compound by itself is neutral. By itself, neutral unless otherwise stated. -1. Oh. So I didn't have to add any electrons, huh? Let me verify that I had that. Same instance here. What am I not taking? Oh, this is 9 minus. That's why. Goodness gracious. Don't forget that that applies to the entire thing. I need to put parentheses so I remember that. This minus means I have 9 negatively charged hydroxides. So this is a minus 9. Alright. So if that is a minus 9 and this is a minus 1, I have to add 8 electrons to this side. Alright, so if this is 8 and the other one the other half reaction was 16OH minus plus 4 zinc. Oh no, goodness gracious, I'm writing a random one. Yeah, I'm writing a random one. Okay, it was the zinc and nitrate and so I just wrote my nitrate one. Oh, so it was zinc and 4OH minus to reduce. And all the H2O's crossed off there, 2 electrons. Alright, so I have 8 electrons up there and 2 down here, so I'm going to have to multiply this entire thing times 4 so that this gets to 8 and crosses off. If you ever get to the point where you've got electrons on the both sides, that's not the case, because if it was oxidized, one side should have released and one should have received, and it's the opposite on the other one. Alright, so we get 4 zinc, and 8 times 8 is 16 OH, each with a negative charge. 4 zinc OH, 2 minus, plus 8 electrons. Now my electrons will cross off, which is the goal of that entire process. And now I'm going to combine it back together. I like to start with the first formula, so now I'm backwards, but the first part that's written so I don't get dyslexic on it here. Slide up so you can see. So I'm just reading that first equation. 6H2O. And then I'm going to add 4 zinc plus 16 OH minus to form, and then I go back up here and write this guy again, NH3 plus 9 OH. Again, I recommend the parentheses just so you don't make the silly mistake I continue to make here. 4 with the 2 minus charge. Alright, double check that I didn't make any silly mistakes here. So we have 16 OH on this side and 9 OH on that side. So I can cross that OH off, and this one is left with 16 minus 9, which gives me 7 hydroxides here. Alright, looks like I am good. And remember, your double check if your nitrogens balance out, if your oxygens balance out, if all of the atoms balance and all of the charges balance, and you didn't magically change one of your compounds, then you did it right. So here is my final answer. Okay, so my tips to you, remember, I started writing out my rules, so I wrote it really, really messy, but remember Leo the tiger says grr, so losing an electron is oxidizing, gaining the electron is reducing, and then you have to determine is it an acid, a base, so in acidic solution, in a basic solution, or neutral. On the quiz tomorrow it's only going to be acidic or basic. So the process for acidic and basic is all the same except so again, split oxidation and reduction. Balance oxygens with H2O. Balance hydrogens with H+. Don't forget about other hydrogens that are present in the formula. Balance any other elements. Like if you've got chlorine present and there's 2 on one side, you have to have 2 on the other. Find the net charge on each side, balance with electrons. Now the only thing that's different is here, for a base, you're going to add OH to balance wherever you put H+, but you have to do it to both sides. And then if you've got an OH and an H+ side by side, you change those to H2Os. And then you continue on where you left off here. Okay, so very similar. Just know that there's no H+ found in a basic solution. They are OHs. Alright, I think that about covers it. Good luck.